Hi, welcome back to the review for the Chem 4 final. And in this video we're going to do an example of an equilibrium question. So, if at a certain temperature 2 moles of PCl5 are placed into a 3.5 liter vessel, and if at equilibrium there are 0.400 moles of PCl3, they want to know the value of the equilibrium constant. So remember, this is important. Unless it's an acid and base reacting, which we don't have, you need to have molarity in the chart, not moles. And the formula for molarity is number of moles divided by number of liters. Now, they're telling us initially PCl5 is 2 moles and in a 3.50 liter vessel. So moles divided by liters, 2.00 moles divided by 3.50 liters gives us an initial concentration for PCl5 of 0.571. At equilibrium, and don't confuse initial and equilibrium, at E in the ICE chart, the molarity of PCl3 is 0.400 moles. So 0.400 moles divided by 3.5 gives us 0.114 molar solution. So let's plug these values into our chart. And again, remember, anytime you have an ice chart or an equilibrium chart, think ice, K, solve, check, and sun. So let's make our ice chart. We already have, you remember you always have to start with a balanced equation, and they give us that in this problem. So what's the initial concentration of our reactant PCl5? We already changed that to molarity, so it's going to be 0.571 molar. Remember, at the beginning of a reaction, you're all reactant. Nothing's happened yet. So these two concentrations of product are going to be 0. The change in equilibrium value, the initial concentration, is always going to be to let x equal the change, and you're going to multiply by any coefficient, which in this case is 1, so I'm just going to leave it as x. Since the reactant's got to lose to create product, we always subtract the x on the reactant side. We're going to add x to both sides here. Notice there are no coefficients that I have to multiply for these x's. So now when we combine them at equilibrium, we're going to have 0.571 minus x. This is just going to be x, and this is just going to be x. So we did ice. Ice, K, solve, check, sun. Let's do our K expression. Our K, and they're asking for K, is going to be equal to the products raised to their coefficients. So that would be PCl3 has a value of x. Our other product, Cl2, equilibrium value x, divided by our reactants raised to their coefficient. And again, our coefficient is 1, so we don't have to worry about that. So I'm going to plug in 0.571. Now remember, for a final exam, I really don't think that they're going to give you something where you need the quadratic formula to solve for x. So for our purposes here, we're just going to get rid of that minus x to simplify our lives. Oh, wait a minute. They gave us the value of x, didn't they? Let me put that back in. What did they tell us? They said at equilibrium there are 0.400 moles in the 3.5 liters. They gave us an equilibrium value for PCl3. So we know this value is going to be 0.114. I'm going to go ahead and plug the 0.114 in every time I see an x. X times x is x squared. So we're going to square this. Divided by 0.571 minus 0.114. Oh, that was a little tricky, see? You always have to be prepared to plug in a given, because if you get stuck, you're forgetting to plug in something from given. Now what do they want to know? Okay, so what is our value here going to be? We've got that. So our value for PCl5 at equilibrium is going to be 0.457 molar. So we could go ahead and solve for K. And our value is going to come out to be 0.0284376368. Now, how many significant figures do we need? Let's go back to our problem. This has a decimal. We're going to start on whatever's here, a 0 or a number. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Our answer has to have 3 significant figures. You always start with a decimal or a number without a decimal. You don't include that 0 as the last number you count. It's going to be 1, 2, 3. So we have 0.0284. That's 3 significant figures. Now, ICE, K, solve, check, sun. We did our ICE chart, we did our K. We solved for something. Let's go back and make sure we solved for what they wanted. Calculate the equilibrium constant. We did that. So we checked to see if we answered the question. Now, SUN. SUN stands for, the S in SUN stands for significant figures. And we did that. The units. Now, what are the units for K? K has no units, ever. No units for K. Do we have no units? Yes. We're good on units, and we have our number, which is the N in SUN. So we are good to go. All right, so that's our example of an equilibrium problem. Remember, they could ask you for K. They could ask you for any of the concentrations, and they will, I assure you, give you enough information to figure that out. Remember, ICE, K, solve, check, sun. Bye-bye.